Hello everyone. In the previous video we have implemented stack using cubes, and in this video we are doing exactly opposite. We are implementing cube using stack. So the functions we need to implement are push, pop, peek and empty. So for this problem what we can do is we will just declare two stacks. So stack integer, so let's call it main stack, and we will declare one more stack. Okay. Too much typos. Okay, so let's call it util stack. Okay, so we will just initialize them in the constructor. So let's say main stack is equal to new stack. Okay, and util stack new stack. Okay, so when we need to push any element we will just push it in our main stack. So what we will do is we will just main stack dot push this x. So while we are implementing pop functionality, so we need to check if our second stack, which is util stack, is empty, and while our main stack is not empty, we will push all the elements from main stack to util stack, and the element which is on the top of our util stack, we will pop that element. So I will explain what I'm trying to say. So let's say we have 1 2 3 and 4. Okay, and I will make empty util stack. So we will name it here main, and this is util. Okay, so as we know, in the stack data structure, if you perform push operation, pop operation, so by that logic the element which we have added most recently will get popped. So by that logic the 4 will get popped, but as per queues implementation, the one should get popped as it is pushed earlier than the other members. So this is the major difference between these two data structures. So what we can do is we will push all the elements in the util stack, so they will get in reverse order. So if we pop this 4 and push it here, so it will be here. So then we will pop this 3 and we will push it in our util stack. Then we will push this 2 and then we will push it here, and then in the last we will push 1 and then it will be here. And if we perform now pop operation, so we will get the element which we want to pop by the queues logic. So we will do this thing. So what we will do is we will check if our util stack is empty. Okay, so in that case we will push all the we will pop all the elements from main stack and we will push them into util stack. So while our main stack is not empty, so what we will do is we will push all the elements in our util stack. So util stack dot push, and we will pop elements from main stack. So main stack dot pop. Okay, so after this process we will just return, or outside the loop we will just return top of our util stack dot pop. Okay, so for peak we will again check if our util stack is empty, as if in any case our util stack is not empty, that means we have already transferred all the elements in the util stack for any, let's say, pop or any operation. So in that case we will just return the top. So what we will check is if util stack is empty. Okay, so in that case we will again while our stack is not empty, our main stack. So we will repeat this process again, which we have done in pop operation. So while this is true, so we will push all the elements in util stack. Util stack dot push and main stack dot pop. Okay, and in the end we will just return the top. Okay, util stack dot pop, or we actually we don't need to pop, we just need to return that element. Okay, sorry. So and when we need to check our stacks are empty, our queue is empty, for what we will do is we will just check both the stacks. If they are empty, if both of them are empty, then our queue is empty. So util stack dot is empty. Okay, so I think everything is okay. Let's try to run this code. Okay, yeah, thank you.